Hello. Okay. Answer the following complete sentences on your bell ringer sheet. If A and B hippos are transformation of the original hippo, which one is a dilation? Explain what you think. Only one of them is a dilation. Do you think that the dilation has a scale factor more likely to be 2 or a half? To go from this original to whichever one of these is the dilation, do you think it's more likely to be 2 or a half scale factor? And explain your reasoning. All right. Polygon Q is a scaled copy of polygon P. New, old. What is the value? If the value of x is 6, what is y? And what's the scale factor? For me, it's easiest to figure out the scale factor first. And I take a pair of sides that I know, one from each shape, and I grab the new guy divided by the old guy. And that scale factor, if I grabbed a calculator, is 0.75 or 3/4. So then to figure out what y is, all I have to do is multiply that 6 times my scale factor. No biggie. And 6 times 3/4 is 9/2 or 4.5. So that's what y is. So in general, dilation, scale factors, and similarity, not congruence. Similar figures, not congruent figures, have the same shape but not the same size. What's also true about similar figures, all the side lengths all get bigger, enlarged, or they all get reduced, but with the same scale factor, a consistent scale factor on each pair of things. And the scale factor, the easiest way you do it is you take the new divided by the original. Ratio of the sides, meaning if I compare a couple of shapes that are supposedly similar, I drew those terrible. If this is 3 and this is 6, which clearly it's not, the scale factor or the ratio there from the smallest to the big gets multiplied by 2. So then if this side up here was like, I don't know, 1, then this side over here would have to be 2. They have to go up by the same amount, the same ratio. So 6 divided by 3 is 2, and 2 divided by 1 is 2. So they have the same ratio. And the angle measures don't change. If this guy up here was 140 degrees, then the same guy in the same spot on the other one is also 140 degrees. The angles don't change. So, you're getting ready to move into a new house, let's say. And the lengths of the walls of your room will be, most rooms are rectangular, 10 feet by 12 feet. But when you look at the blueprint, so you've got this paper and it shows your room and it says that it's 7.5 inches by 9 inches. What's the scale used on the blueprint? Okay, now we got to be careful. We're going from feet to inches, so we have to be careful. It's easiest to do this if we stick it all in feet. So how many inches, if we stick it all in inches, how many inches is 10 feet? Well, that's the same as 10 times 12, which is 120 inches, right? And 12 feet would be 12 times 12, because there's 12 inches in every foot. And 12 times 12 is 144 inches. So I'm not looking at 10 by 12 feet anymore. I'm going to look at 120 by 144 inches. So now if I use a scale factor, new divided by original, and I'm going to get very lazy and not write out the whole word. Oh, no, I will. New divided by the original. I just pick a pair. You get to decide if you want to do the 9 and the 12 or if you want to do 7.5 and 10. I don't want to deal with 7.5. I don't want to deal with fractions. So I'm going to do 9 inches and 12 feet, but we said 12 feet was 144 inches. And you can grab a handy dandy calculator or your brain to reduce that fraction, or to turn it into decimal, either way. But the scale here, 9 goes into both of those numbers. So if I divide the top by 9, I get 1. If I divide the bottom by 9, I get 16. So my scale is 1 to 16. 1/16. All right, so now we've got an Etsy shop, and she's making some coasters that come in 2 sizes, small and large. To make the coaster, she creates a template for the shape on her computer and then enlarges it. So this guy is the new, also known as the image, right? If we're going to use fancy geometry. And this is the original, also known as the pre-image. Okay. Find the missing dimensions on each coaster and solve for x. Well, you know what? I'm going to start with the easiest. I'm going to look for that angle that's missing. Angles don't change in similar figures, so it's 124. Done. Doesn't change. Now I'm going to figure out the scale factor. And I'm going to take a new divided by an original. And you know what? I don't think I want to use 19.5 and 13. I mean, I could, but I could also use 18 divided by 12. It doesn't really matter as long as you pick a pair and you do the new divided by the original pair of sides that match up. And it turns out 19.5 divided by 13 is 1.5. So that's my scale factor. So if I'm going from the small original to the new one, all I have to do is multiply by 1.5. So if I'm going to find this side up here, then I'm going to take this 4.5 and multiply it by 1.5. 4.5 multiplied by 1.5. And you do that, you get 6.75. So that guy is 6.75. And then let's see what else we need to find. Well, I got to find this side on this shape. Well, I'm going to go backwards. So I'm going to divide instead of multiply. So 14.25 divided by 1.5. And what does that equal? 9.5. So that's what that side is. 9.5 right here. Are there any other things that are missing? Oh, this guy. All right, I want you to figure that one out. Bum, bum, bum. Last one for today. Coca-Cola standard Coke can is 6.25 centimeters in diameter. That means across the circle on the top. And has a height of 12.25 centimeters. They're thinking about making little baby cans that are similar. Ooh, they are similar with a diameter of 4 across the circle on the top. And they want to know what the height would have to be. It says show 2 methods for coming up with your answer. I'm going to show you one. And then you come up with another method. Okay? So I'm going to find the scale factor by doing the new divided by the original and the pair that I know. So 4 divided by 6.25. That scale factor gives me what? 4.625. I don't know. I'm going to let you figure it out. Then whatever that scale factor is, we'll multiply that 12.25 by the height to figure out the new height. Womp womp. So there's one way to do it. Kachiga.